So here's example 2. It has the same directions as example 1. So what I want you to do is go ahead and pause the video. I know we've only done one example, but pause the video and see if you can work this the same way that we worked example 1. All right, let's see how you did. So first we were trying to decide if we could actually find an inverse or not. Finding that f prime tells us that f prime is all above the x-axis except for at 0, so kind of similar to example 1. So that means that f is increasing except at 0. So strictly increasing except for at 0. Therefore, we know f prime exists. And then going from there, using our formula here for the f inverse prime of 26, because that was our a value, we've got 1 over f prime of f inverse of 26. Like we said on that last example, if I'm trying to find f inverse of something, I can plug it in as a y value in f, and whatever x value comes out will be the y value in f inverse. So plugging in 26 for my y value in f of x, I'm going to end up with 3 as my x value, which means I have that point 326 on f. So switching them, I have the point 26.3 on f inverse. So I'm going to have my 26 here, or sorry, I'm going to have my 3 here. And then my last step, my f prime of 3, just plugging that in for the f prime that I would have had to find over here to find that it was monotonic. My f prime of 3 ends up being 27. So my f inverse prime of 26 is 1 over 27. So for our last example, we're going to throw some particle motion into the mix. So we've got a particle that's position is given by f inverse of t, where they give us f of t is just 3t squared plus 1. This is not a typical type of problem to have inverses in a particle motion problem, but I just wanted us to recall something older that we've learned and then keep using the inverses as we're still working on that. So first, let's name this particle Fred. I think that's important because, you know, yeah. We were trying to figure out when Fred's velocity is t equals 4. And what we have to keep in mind here is that his position is not given by just f of t, it's given by f inverse of t. So that means if I'm talking about his velocity, that I have to be taking the derivative of f inverse, not the derivative of just f of t. So his velocity is going to be given by this f inverse prime of t. So that's a little trickier to work with. But I'm talking about a specific point. So if I'm trying to talk about just at t equals 4, that means that I'm just trying to figure out f inverse prime of 4, which is what we've been doing. So we're looking at 1 over f prime of f inverse of 4. And then how are we going to find f inverse of 4? I hope you knew. In order to find f inverse of 4, we're plugging in our 4 in for f of t, because that would be like the y value in f of t, and then solving for our t value. That's going to tell us what time this is happening at. Let's see. And we get that t equals 1. So if we had the point 1, 4 on our f of t, that means that f inverse of t has the point 4, 1. So now we're trying to find f prime of 1. So I do have to go back up to this and find that my f prime, first of all, is going to be this 6t. and then plugging in my 1, my f prime of 1 is going to be 6. We did end up with that answer before. That is just a coincidence. I made up these numbers, so I am baffled. 1/6 happened again. So this would tell us that Fred's velocity when t equals 4 is 1/6. I don't know what units we're talking about here. I don't know. Something per second, probably. Feet per second. It's pretty slow. I forgot to mention here that we did know that F inverse existed. We didn't talk about that a whole I forgot to mention on this last problem that we did know that F inverse existed, first of all, because they told us that the position was given by F inverse, but also just deciding whether f of t had an inverse. It's not strictly monotonic for all values, but it is strictly increasing. If we think about what 3t squared plus 1 looks like, it is strictly increasing when values are greater than 0. And since we're talking about time, that's really all we're worried about. So definitely going to have an inverse for our values of t for time being greater than 0, because this guy was increasing when t was greater than 0. For those of you that are still planning on taking the AP test, I just wanted to encourage you with this, that yours is the first in the history of AP tests that I know of that is going to be open note and open book. So for a topic like we just covered, the derivatives of inverse functions, the beauty is that you can have a cheat sheet of all derivative rules, integral rules, whatever. And so this isn't a topic that you really need to memorize as much as you need to be able to use if need be. So kind of taking a little bit of stress off of you that you're going to have so much less to memorize than past students who have taken the AP test. Now yours might be a little bit more challenging in the application, but as far as studying those derivatives and integrals, as long as you have them handy during the test, I don't see why you would need to memorize them all. So keep up the good work. You're doing great.